Değerli katılımcılar, oturumumuza Top Battery, teknolojiden sorumlu Genel Müdür Yardımcısı Sayın Yongberoh'un Pil Teknolojilerinin Geleceği konu sunumu ile devam edeceğiz. Dear attendees, we will continue our session with presentation about future battery technologies by Mr. Yongberoh, the Chief Technical Officer of Top Battery.
Good morning, everyone. I'm sorry to say this. Today's my pronunciation is a little bit weird because of wearing the mask due to the pandemic. My topic is the future of battery technology. Okay. The main contents is divided into three categories. First, global market, future material trend. Second, the future material development. As you know, the lithium-ion battery consists of four main components: cathode, anode, electrolyte separator. Today, I just focus on the cathode material because cathode material is the most expensive component among them, and then play a key role to realize the high capacity battery development. Finally, I want to explain the further cylindrical cell design. That is for further understanding what kind of product will be made under the strong relations between ASPİLSAN and the Top Battery. Okay. Because of pandemic situations, global LRB demand in 2020 is going down 288 to 232 gigawatt hour. Even so, the LRB market will be expected to fast grow until 2030, because the EV market is expanded rapidly. The major battery players are developing the high energy density battery by using the high nickel concentration cathode material. LG Chemical, Samsung SDI, SK Innovation, altogether is increasing their batteries EV driving distance using the high concentration nickel cathode material like NCM, NCA, NCMA material. So we have to keep an eye on high nickel cathode material. Major cell makers is fiercely competing to secure high nickel cathode material by long-term contracts with CAM material suppliers due to the concerning about the shortage of high nickel cathode material. But high nickel the material makers say that the high nickel materials have higher technological the entry barrier, and need several years for the formal the factory operations due to the safety concern and the complicated process control. So China companies initially focused on the LFP material, highlighting the low sale price. But they also are shifting to NCM material to realize the high capacity battery. As cathode material development trend, two kinds of material will be listed up in terms of the cost effectiveness. One is the high capacity material development, over 200 milliampere per grams, including the high nickel concentration over 80%, like the NCM, NCA, NCMA. Another one is the high voltage material development with 4.7 average voltage, cobalt-free, like ADAM-NO. From next slide, I want to explain more detail how to develop this kind of material. To develop the future cathode material, there is several main factors like doping, passive control of crystal structure, size tailoring, and morphology control. There are several cathode material development strategies. Doping is one of the popular strategy to control band gap and electronic structure and improve the structure stability and the thermal stability. It need enhanced ion electron transport. Surface coping is composed of the barrier layer to protect active material from electrolyte and prevent electrolyte decomposition. It leads to stabilize the surface reaction with the electrolyte. Through morphology and crystal structure control, we have to select the preferred particle orientations, easy to release the internal crystalline strength, and to optimize the crystal structure and the fast control for fast lithium-ion channels. The tailoring crystal and the particle size is crystal factor to facilitate the lithium-ion diffusion rate. Also, a functional electrolyte is important to build the SCI layer on the surface of cathode material. It is lead to enhance the electrochemical stability of cathode material, especially a high nickel cathode material. These are the representative high nickel cathode materials. Polycrystalline cathode particle is composed of the secondary particle with the smaller primary particle combined together. But the single crystal cathode particle only consists of the larger primary particle. N is the nickel, C is the cobalt, M is manganese. 5:3:6:2:8:1:1 means the molar ratio. The more nickel concentrations, the larger cell capacity is realized. Electrode density is like this, and the reversible capacity is like this. In the real battery industry, the volumetric capacity is more important than the reversible capacity. So the single crystalline cathode material is the most promising cathode material among the high nickel cathode material. But the mass production is early stage. So Top Battery is now developing the single crystal cathode material in-house. This is cathode material degradation, especially high nickel cathode material. It is known to be chemomechanical degradations. During charge state, the balance of a nickel atom in the particle surface part is changed from the nickel 2+ to nickel 4+. This nickel 4+ is well known to be a very active reaction with electrolyte. It's need to nickel oxide impurity, the Lockshort phase. Meanwhile, there is the microcrack generation in the particle core parts, which is progressed to surface of the spherical particle. Electrolyte impregnated into the crevice of the spherical particle. It need to NIO impurity. During charge state, crystal structure also was changed from the layer structure to Lockshort phase. In this material degradations, a lot of lithium get consumed and the cell capacity is decreased, and then cycle up is shortened by the huge the crystal structure damage. So how to improve the high nickel cathode material performance? First, we can think of the doping process. As I mentioned before, the titanium is good for strengthening the structural stability because due to the strong bending structure with the oxygen, and lowering the charge transfer resistance, and it leads to enhance the cyclability. Second, the partial crystalline structure turn out to be good for the cyclability. Partial structure means the surface is nickel-less concentrations. Core is nickel-rich concentrations. One of material supplier in Korea is now producing this kind of material as mass production. The dual coating is one of the best solutions to protect the surface of high nickel cathode material from electrolyte decomposition. In this dual coating process, Li3PO4 is good, effective for electric conductivity enhancement. Polypyrrole is the protect the side reaction with electrolyte. It leads to enhanced cyclability. The final option is morphology control. We have to select the prepared first the primary particle orientation as load shape. Each to release the crystal structure strain, which is accumulated by the crystalline expansion and contraction during cycling. At the same time, the fast control of the C-axis is effective for the fast ion diffusion. It leads to enhanced cyclability. This all kind of approach will be effective for their cyclability enhancement and high capacity battery. From now on, I explained the cutting edge technology in the battery industry. Up to now, we have thinking about the particle level to improve cycle life and high capacity. But it is important that we have to take our technical mind to the electrode level. The tech-savvy engineers always are thinking about the volumetric energy density on the electrode level rather than the theoretical energy density in the particle level. The polycrystalline particle generally have a low packing density. The partially collapse of surface particle under the high pressure and appeared reaction of heterogeneity in the electrode during charging and discharging. But the single crystalline particle generally have the high packing density and the excellent morphology maintenance under the high pressure and appear the reaction of the homogeneity in the electrode during charging and discharging process. I show you one of the examples, the directly understanding what appears on the electrode level under the high pressure. The polycrystalline particles are severely collapsed and high electrode density, but the original morphology of a single crystalline particle are stably maintained on the high pressure like this. So if we combine properly all this kind of approach, we can develop the high-test cathode material. One of the approaches to increase the energy density is to increase the cell voltage. Because the energy density is calculated by multiplying the cell voltage by the current amount. The NCM price is expected to be increased sharply due to the limited resource of cobalt. But aluminum spinel does not include cobalt. With the small amount nickel amounts like this. And then there has the 5 volt flat discharge potential like this. So the aluminum material is much cheaper than any other cathode materials. So aluminum material is one of the solutions for battery maker who thinking about the cost effectiveness. The aluminum material also have the high specific energy density. The following by NCM A11. The specific energy density is in following order: NCM A11, LNMO, 622, LFP NMO. So you understand how to how the aluminum material is have a good balance between the energy performance and price. Aluminum material has the good cycle life and high late discharge capability. Also, aluminum material has great advantage to use water-based binder instead of conventional NMP-based binder. As you know, NMP is very toxic and classified as the environmental hazard. So the battery maker can the benefits a lot from reducing the utility investment cost like the NMP solvent recovery system. We can hear about the EV catching fire from time to time, and the frequency of EV catching fire is increasing sharply these days because of the usage of the high nickel cathode material. The aluminum material is a high temperature safety characteristic. Onset temperature is following order: LNMO, LFP, LMO, LCO, NCM A11. A peak temperature like this. So I think the aluminum material is one of the alternatives to NCM material in the future. We are developing the next generation cathode material like the high nickel single crystal and the aluminum material. This is our next generation material development roadmap. We are now producing the low-cost NMO and developing high-capacity NCMA materials. The NCMA material first target is to have the high-capacity anodes with 3,000 watt/kilograms. It means to be possible to get the EV car to drive the 500 kilometers on a single charge. From now on, I briefly introduce solid state battery and solid electrolyte. There is a third category to the research the solid electrolyte. classified as the main chemical components. As the sulfide, solid electrolyte, oxide solid electrolyte, and organic, inorganic, the composite polymer electrolyte. With each electrolyte has their own characteristics. As for the high conductivities, you can select the sulfide solid electrolyte. Toyota, Hitachi, Samsung, LG is researching this area. If you want cell stability, you can choose the oxide solid electrolyte. Murata Prologium TDK is focusing on this area. And then if you want a high productivity, you can research the organics, the composite solid, the polymer electrolyte. The hydrocarbons, the Bosch, solid energy is researching this area. This is one of the solid electrolyte concept. For high ionic conductivity, we have to reduce lithium-ion activation energy by securing the wider diffusion paths and more flexible frame structure in the crystal, and reducing the bonding strength between the lithium ion and anion. The Prologium is now producing the all solid state battery using the oxide solid electrolyte. They are using the web process, load-throw process to increase the cell productivity. But I don't know what kind of concept are applied. This is another one solid state battery production example using the oxide solid electrolytes. The Japan company is like the Murata and the TDK. As you know, the Murata is the world best capacitor provider in the world. They are producing this kind of all solid state battery, fully utilizing their MLCC facility and the process and knowledge. This kind of all solid state battery have the long cycle life and good rate performance, but limited capacity and lower average voltage compared to the conventional lithium-ion battery is the disadvantage. Okay, that's all. Today is my presentation and thank you for your attention.
Sayın Yongberoha, sunumları için teşekkür ediyoruz.